The slides and an entire cloud folder is available for you to download. So you can scan the barcode, or you can just go to this link by yourself and download everything that's over there. Let me try and show you what the cloud folder looks like. So this is the cloud folder. This is our workshop. There's a few other workshops that I borrowed from other people in our big early career researcher team. So we have Luca and Amir over here who did their R workshops. So I took some slides and some code from them. So you're welcome to also, of course, go and have a look at this. In the code folder, there's this 2021 RMagic.R. This is the main file that we'll work on, plus a bunch of other data sets that I'll demonstrate for you. You want to look at the presentation, there's not much there aside from like a main slide and a few background slides. So this is under the presentation. And a bunch of other stuff that's in here. I think the most important one is these guides, books, video, and workshop. So once again, for those who just joined now, there's a cloud folder. The cloud folder appears on every one of these slides over here on the bottom right. Occasionally, I will try and paste this into the chat. But if you download this, go over and have a look at this Dropbox, then you'll see a bunch of things. The most important folder in that Dropbox is this guides, books, videos, and workshops. So if you'll go in there, I've collected a bunch of stuff for you. So you've got our resources, other workshops that are not for me, people who do much more advanced stuff than I do, including Amir and Luca, that I borrowed a bit from. Then we have books. This is a little bit outdated. I'll show you where the updated stuff is. So this is from like 2020. So you've got a bunch of them. All of them are open source, open access, open everything. Amazing contributions by the community. So it shouldn't be a problem for you to find something in here that addresses what it is that you need. Some courses online. So there's some links that you can go here and have a look at. From regular frequentist to Bayesian, how to install stuff. So perhaps in preparation for this workshop, you've installed the R and RStudio, how to install it. You have a PDF here that explains this. Plus, I gave in the abstract some links to a YouTube video that explains all of that, plus some articles about the tidyverse, not that important. Just a bunch of some examples from a bit old by now. Welcome. It's good that you came to join me on this. I occasionally try and give some workshops here at HKU. Everything that we are going to do today is recorded. Everything that I do is uploaded to YouTube. So if you want to go and have a look, everything is on a YouTube channel. So you can at any time go and subscribe. This too will be uploaded at some point. As you see here, you have a bunch of playlists. In the playlists, you have things like open science workshops. So I'll upload this to the open science workshops after the workshop is done. Plus, if you want all kinds of talks that I do about open science and my research, you can go over here. Plus, all the courses that I give, everything that I do is also available to you on YouTube or on the open science framework. So if you feel like maybe you missed something, or you want to go back and check, or you want to revisit, or you want to share with somebody else, no problem. Everything is recorded, everything is uploaded and shared. So feel free to use this in any way that you want. It's all for you. No problem, copyright and whatnot. Just do what you want with it. So here's what I was thinking of doing today with you. I think given my experience, so what I was thinking of doing, I think that the biggest barrier with R, and one of the reasons why here at HKU we still haven't moved to R, because people perceive this to be really complicated. And I've attended a bunch of workshops. I try to go to workshops, even if I know what R is about and how to handle R, just to see how people present R and how students or participants kind of react to R. And I think the main problem is that R is really scary. It looks scary. It looks like a programming language, and most of us did not come to the social sciences or whatever it is that you're doing in order to mess around with code, or we don't have the experience, the expertise, or the inclination to learn anything about coding. So it's really scary. We like our dialog boxes and the point and click, which is why I think many of us are addicted to solutions like SPSS. Here in the department, it took us a while, but slowly we've migrated to JAMOVI. So I'm going to talk a little bit about JAMOVI and how this JAMOVI interacts with R. So JAMOVI is a good step in between, and I'll talk about JAMOVI and why it's an important step to R. But I think the most important thing for me to do, so rather than take you step by step of how R thinks, how R works, how you need to align yourself in order to adopt the programmer mentality, I'm going to try something a bit different. I'm just going to try and show you how easy R is if you don't try to fight the R system, if you don't try to program. The basic skills that you need in order to follow what it is that I do here is to be able to do copy-paste. So copy-paste is our superpower here. Hopefully, if I go too fast because something is too obvious for me, then do stop me and let me know. I will try to do this as slowly as possible, assuming that you don't know anything. And hopefully, if you do know something, at some point I'll arrive to where you are with your knowledge, and you'll be able to kind of get something that will also be helpful for you. I will use things that are not in the R ecosystem, but rather using R in order to provide something else. So I'll show you a bunch of tools that are available to you within RStudio and the R platform, or outside, let's say on a website, in order to help you with your journey into tackling and being able to overcome the challenge of R. What will I do? I will discuss very broadly the R and RStudio environment. I'll show you what that looks like. If you've installed this, you're welcome to kind of do this together with me. I will go through very basic R code. Before going into the code, I will show you alternatives to the code. So first, I'll show you how to do this without code, and then I'll show you how to do this with code. I'll introduce you to a few of our guides. So we have some amazing guides that I started as a collaborative guide, but I did not put all of the information in there. It became kind of like a community initiative where everybody comes in and updates. Some of those have been led by members of our team, some of the early career researchers or students that have worked with me or are working with me. And for almost every one of these guides, there's also some tutorials that the teaching assistants that work together with me in my courses have done, or a workshop that I gave. Some of the tools that I'm going to be mentioning in order to simplify your life are the RCommander, Statscloud. I don't know if you're familiar, but it's a relatively recent advance, something that's really neat. It's a web app that runs on our exports R. So it allows you to do some really neat stuff. JAMOVI, perhaps you're familiar, but not a lot of people using JAMOVI actually know that JAMOVI runs on R. Everything that you do in JAMOVI is R. So I'm going to show you the R behind JAMOVI, and I'm going to show you how JAMOVI and R talk to one another. So that basically you can do whatever it is that you want with a point and click in JAMOVI, and then you can just copy and paste our superpower, copy paste into the R platform to be able to build on this even further. Another neat project that's right now in beta, so it's just starting out, and hopefully, I adopted JAMOVI in 2018 when it wasn't really anything very spectacular, but now it really is stable, it's very, very mature. Hopefully this will happen with Statsnotebook, and I'll also mention R RMarkdown. I won't go into programming a lot. You have a lot of other ways to do this. I'll show you one of the ways in which you can learn how to do this. I'll show you some stuff in our R RMarkdown guide on where you can find more resources. You've seen the cloud folder where you can find all the wonderful things, in the guides, books, and videos and workshops. So you don't need me for this. You just need some time to sit with yourself and be able to tackle this. And it will become easier with time, I promise you, but it will be a lot easier if you use some of the tools that I will show you today. So I'm assuming that you're ready to get started. Enough said. Let's go to the RStudio. So here we have the RStudio. So this is our RStudio. It's an IDE. It runs on R. If you want to see what R really looks like, this is what R looks like. It's over here. It's what's called the console. But I can also open the R on its own over here. So if I just open the traditional R, the way that R used to be before we had RStudio, this was R. I think a lot of people back then, the first time that I saw R and I saw this kind of interface, and I was thinking to myself that this is impossible, because basically you have nothing here. It just expects you to start punching, and you don't really know what to do. So not very friendly. But over here, there's at least something that looks a bit familiar. That there's a big window, and it allows you to do all sorts of things. And you've got menus up on the top, and we need to kind of understand some of these menus, but most of them we won't be using. And I just, it's meant in order for RStudio to do these wonderful things on top of R. So R is the programming language, and it runs on the bottom, and RStudio runs on top of that in order to provide you with some services in order to be able to, for example, here on the top right, see what the environment is, look at the history, run tutorials. I'll show you how to use this. Here you have the code. So when you look at this code, you have the number of the row where you're at. And then for each one of these rows, you have the ability to execute this. So over here, you have this run button that we'll use quite a lot in order to go step by step. Each row is a line of code that needs to be run and does something. Some of the output will come out in the R over here in a text sort of interface, and some of it will be over here on the right where we have a plot, where we have a viewer. Plus, there's all sorts of things that you can do over here in order to look things up as help, or look at all the packages that are currently installed. So looks a bit intimidating. Let's see what we can do here. Let me just explain the very basics of R. Just like syntax, every time we have something that runs, there's actual lines of codes, and there's ways for us to document what these lines of codes are doing. So everything that starts with these hashtags is actually a comment. It's not something that you can run, but over here you've got actual R code, and as you can see, it has different colors. So RStudio really tries to make this very visibly appealing, visually appealing for you to see the command and what are the attributes, what is the function that you want to run. And over here in the first set of commands, what it actually does is it runs packages. So perhaps we need to explain a little bit what a package is. A package is a group of functions. So it has a lot of lines of code that somebody else has written for you that you can load in your own environment in order to use this for what it is that you need to do. It's not really important for you right now to know what each one of these lines of code is doing or what these packages are doing, but we want to use some of this functionality. And typically when we want to install something, we run this kind of line. We run install.packages and then the name of the package that we want to install. But here, what this one does is that it runs a lot of these installations together. So instead of having a bunch of lines that just repeat install package, install package, install package, it just runs and installs all of these packages together. So for now, the only thing that you need to know is that all of these packages are going to be loaded. And because R on one side needs to install a package and then it needs to load it to memory, what these lines actually do is that it both makes sure that this is installed and also runs this. How do we run stuff? We have this run button over here. So whenever we stand on a certain line, so now I'm standing on line 13, and I do run, you can see that it transfers this command over here to the console over here. So basically, R receives something from RStudio and runs it. And the only thing that this line did over here is that it created a variable called list of packages, and it inserted all the names of all these packages. So actually, you can see over here in the environment that there's a variable that's called list of packages, and it has all these names of different packages. And now we want to see which ones need to be installed. So there's something that we can do in order to see which ones are installed and which are not. And if it's not installed, then it tries to install it. Another thing that you can do, rather than just stand on each line and do a run, is select a few lines together and then run a bunch of these lines once at the same time. So if I do all of this, you'll see that it actually copy pasted. And what it does in background is it makes sure that everything is installed and everything is loaded. Now, if you run this, this is, by the way, available here in our code. So this is this file. So under the cloud folder, the R workshop, it's the file 2021 R magic. So this is the one that we're working on. So if you do what I just did now, so you select all of this and you do run, it will take a lot of time because perhaps you don't have some of these packages. So what it does is that it connects to the web, goes to the repository, downloads this from the internet, opens this, then installs this, and then loads it. So for me, because it's already installed, it takes a very short time to actually install. How do you do this if you don't do it this way? So let's say, for example, I want to install this TMB. Actually, I can go here to this side over here and do install. And here I can say, I want to install this from this repository. So I want to install TMB. And then it will show me as I type what are the packages that are available. So you can do this through a line of code, or you can actually go and do your point and click and punch in some stuff, and then install whatever it is that you want to install. Plus, if it needs some other packages, it will also install the dependencies. That's why if you install something that's very big, like the tidyverse, it might take a very, very long time because it depends or it includes many other packages. So sometimes you've got mega packages that include a bunch of other packages. The packages are basically a big collection of code that we can use in order to do something for our own purposes. Now, there's a bunch of that I prefer to do in order to simplify the way that it visually looks for you. This is just the formatting of numbers. So rather than having this, exponential view of numericals, this does something else. So I'm just going to run this. It's not really important that you understand what this means. What these two lines do is just, it's a tweak that I did. Over here, you can see that there's a working directory. So R depends on a working directory, and sometimes the working directory is not as the same as the file that you're working on. If you're just working with yourself, just like I'm doing right now with this workshop, I want to set the path to whatever this is, because I want to load some of these data sets in order to be able to show this to you. So in order to ensure that we are pointing to the same directory where the file is, I just run these two, and then it updates where the working directory is. You can also, do this yourself. You can actually set your working directory by opening this over here, looking at all your files. We won't go into this right now, but there's a way for you to create a project and include some files in there, and then make sure that all the paths are related to one another. But that's just like a technicality. Now, I want to show you how to get started with R. We're not going to go a lot into this. The purpose of the workshop is not to train you on how to program R, but I do want to show you how you can learn this very easily. This is some of how I learned this. And I think the best way to learn is learning by doing. So if you see somebody else doing lines of code for you, or going step by step and telling you what it is that they're doing, you don't feel the same kind of engagement as when you're actually doing this on your own. And there's this one really cool package called Swirl. So we can load this package. So it's been loading. And then if we run this, so this is a function. Functions are, you know, the name of the functionality that you want to run, and these parentheses, the kind of brackets. And then if we stand on this and we run this, they can either push run over here, or sometimes you'll see that I won't go here every time. I just press Control Enter. So Control Enter also does exactly the same thing. So if you stand on this, it says run the current line or selection, Control Enter. So you don't want to run back and forth. So you'll do Control Enter. And as you can see, what it does over here is that it started something, and it says, welcome to Swirl. Please sign in. If you've been here before, it remembers you. So please use the same kind of name. So you can actually use your own name. But here we're going to call this like a workshop HKU. And if we start this thanks workshop HKU, let's cover a couple of quick housekeeping items. So you can progress with the instructions of what to do. But as you can see, the tutorial is actually inside of R. So whenever there's like a selection, it tells you you can select between 1, 2, and 3. Then it gives you a selection, and then it interacts with you. So you say, please continue. And then it gives you some basic functions that you can do if you want to skip a question, or if you want to finish with Swirl, or if you want to get some more information, like what you see over here. And if you're ready to do this, one thing that you can do here is you can select to learn R programming, which is really cool. If you want some other things about advanced data manipulation or machine learning or whatever it is, they have a bunch of stuff, and you can even get credit for this in Coursera. So they interact together. So if you complete one of these, then it will credit you, and you'll have an option to go to the website and do something with this. So we want to learn something about R programming, and we want to do this ourselves because I didn't have time to show this to you. So I'll just walk with you one of those just so you see how simple this is. So you select the basic building blocks, and then it says in this lesson, we will explore some basic building blocks of R programming. So if at any point you want more information, you just, you do this, help start. But I'll just show you how easy this stuff is. So in its simplest form, R can be used as a calculator. So all this platform is just for you to be able to compute 5 plus 7. So we're going to use our superpower copy paste. We're going to copy paste 5 plus 7. And if we enter this over here, it will give us the output of what it is that we just ran. And it will give us some feedback on whether we did something correctly or not. So it shows you what it is that you need to do. And it checks whether you did this correctly. And then it gives you some feedback. And if you did this correctly, it takes you to the next step. So So if you don't want to repeat many times to retype this again and again, you can actually create this in a variable and enter this into a variable. And this is where we have this assignment operator. So you can think of this as like an equal sign. It's almost the same, but this is, you can create a variable that takes this 5 plus 7, and it will show you how to do this. Yes, so to assign the result of 5.7, which happens to be 12, into a variable that's called x, it's asking you to type x receives the value of 5 plus 7. So you take this again, and you copy this in here, and you run this, and then it tells you, keep up the good work. So you keep on going, but as you can see, when we ran this, it didn't do anything. It didn't put, it didn't give us 12 like it did over here. So it's missing. So what happened here? It created a variable. Where do we see this variable? So if we go over here on the right, actually we can see that x received the variable of 12. If you remember this thing that we did with the directory, the current directory, so it has my directory under the Dropbox of this code. So every time we have a variable, we actually see this in this environment over here. We have this variable, but now we want to look at this variable. How do we look at this variable? We're going to keep going. And then it tells you if you want to view the contents of this variable x, just do x. So as you can see, very straightforward. So even if you're very scared of R and how do we do things and we're not really sure, it takes you really step by step. And and tries to, and it gives you a bunch of tests. So now we want to store the result of x minus y. So we do this kind of thing, x minus 3. Okay, so it gives you some feedback, and then you make progress. Each time you learn something new. If you want to just see how far this goes, you can do skip. So we're going to skip a few times and see. So it becomes more and more complicated, like a bunch of numbers into a variable, and you can see that it does this for you. So you can skip many of these steps if this is too easy for you. This also shows you that actually you can get some help. So whenever you want to look something up, for example, you wanted to see what this C here, so there's a function here that's called C, how to look up this C, you can actually do question mark and C, and voila, over here on the right, you have the help, and it tells you that C is part of the base, the core of R, and it tells you what it does, combines value into a vector or a list. So now we have this Z, and it includes these 3 numbers over here. It's a list that was created. So you have a bunch of examples even at the end. If you want to look up anything else, so before I was looking remove outlier, I wanted to see what that's like. So you just punch it in, and then it loads up everything. So if there's something that you see in a code and you're not sure what exactly is this, so for example, we want to know what is this set WD? What did I do just like a couple of minutes ago? So I can just go here, do set, get or set the working directory. And now we know that this was meant in order to change the working directory of R to the same file where this code is. So this should show you some of the, very easy, straightforward tutorials in R. So even if R looks a bit intimidating, there's a way for you to familiarize yourself with R. You can install all kind of other courses. So now you know that this question mark actually indicates that you can look up the function of installing courses. Now, since we're still in Swirl, we want to know how to get out of here. So we do this info again. And now it reminds us that if we want to get Swirl to exit, we do bye. So we're going to say goodbye to Swirl. Bye, Swirl. Now, if let's say that we want to go back to Swirl, we can do that. We can just go back to the Swirl here, the same line, and run this again. And if we run this again, it will ask me, how should I call you? And if you give it the same name that you used to begin with, it will remember you, and you will continue from exactly the same spot. So yeah, you can start a new one, do whatever it is that you want over here. Yeah, so let's exit this. Whenever you want to resume, whatever it is that you've left, you can say bye-bye Swirl, and then come back to Swirl and continue from where you were. So that's kind of like to show you that R can be friendly, and there's a way of learning by doing step by step where you get feedback, and plus you can get some qualifications from Coursera if you've done all the modules well. So I suggest get like half an hour, maybe once a week or once a day, like depending on how fast you want to go, and just do these. And after you do them for a while, it will become very familiar. So once you complete this, you really know all the basics. Now, typically, like the first session that I ever did with R, in order to familiarize myself with this stuff, is when I was at Maastricht University. So an hour away was Daniel Atkins, and he gave this kind of code. And we did this step by step, which is exactly what Swirl is doing. So what we did here is, X gets the 4, and then X becomes 6. So you can see it changed over here to 6. And then what is X? So running strx, or running a class X. So this is actually the number. The number is 6. And what class is it? Is it numeric? So if you want, all of these files are available for you. So you don't have to do the Swirl. I gave a number of examples. This is the Daniel Atkins example. I think he also uses this in his course. He shows a bunch of things. So for example, A receives 5, B receives 9, and then you can do all sorts of things like Boolean ones. So in C, you can see this is the true. Another version that's a bit more elaborate, this I think was in 2015 or 16. I can't remember, that was a while ago, like 6 years ago. A bit more commented and updated is this wonderful one that Amir gave when he was in South Africa, I think. So this has really a lot of comments. So once again, you can go like step by step and just do run. So when you do this command over here, what it gives you is 1, 2, 3, 4, 5. So from 1 to 5, enter this into A. And if you want to print A, it will show you 1, 2, 3, 4. So really the basics of what R is. So now that we know that we have Swirl, we have Daniel Lakins, and we have Amir in South Africa to help us with all of these, plus a million other courses, I'll let you play with this and do whatever it is that you want with it. But this involves code. You do need to code for this. And you came here for this workshop in order to, now that you know that you can do Swirl, you can do Lakins, you can do other courses, dedicate some time for this, go through this by yourself. Now I want to show you how to do things rather easily. And one of the first things that we want to do is we want to load some data sets. So when we load data sets in SPSS or in JAMOVI, it's really easy because we go to we have these dialog boxes, and typically we have something like import dataset. Oh wait, we have this here as well. Yeah, so we can import also in RStudio. So just like SPSS or just like JAMOVI, we can also go over here and import datasets. We can import Excel, SPSS, SAS data, so whatever it is that you're working with right now, RStudio allows you to do this fairly easily. So let's say, for example, we have a dataset with SPSS because this is what we're using right now. So I'm going to load this one. It's called toothgrowth.sav. You can see I haven't used SPSS in a while because it's not really registered to anything, but we're going to use this one. So I'm going to open this one here. I'm going to open this data set. I'm going to point it to this working directory, and I'm going to load tooth growth. What you can see over here is that actually it shows me what the data set looks like. And it gives me the code that I need to run. So I don't need to guess anything. I can just, copy and paste our superpower. Take this and import this into your code, and then you can just like basically copy paste this and run this the same way that you would run anything else. That's a big improvement of what used to happen with R, because now you have the tidyverse, and this Haven thing is part of the tidyverse, and the tidyverse can really load anything, so whatever it is that you're using, Excel, SPSS, SAS, it can read it and read it quite well. So you see that in order to load data sets, we thought that this is going to be complicated, but it's really not. If you want to see the different kind of commands, for example, if you want to read empty cars that save into empty cars, then you run this line, so path lines or stata. And there's also another package that's called read R that loads CSV. So you don't need to actually remember any of these commands. You can do over here and from text base. So this loads CSV, or if you want to load Excel, you just go here and it will give you all the commands. So this is a different package called readxl, and it runs this kind of code. But you don't need to remember this because you have point and click, which is what we're here for. We want things to be easy. Plus, if you have your own data sets, so let's say that you want to copy paste this from your own data sets. For example, let's say that we open this tooth growth. Here we do have, this typical. So we have 3 columns, and they have various, values. This is a continuous one. Here we have 2 kind of categories, and in the third one we have 1, 2, 3 categories. So we have continuous, categorical, and categorical. If we want to just, for now, copy paste these kinds of variables, one of the packages that you can do is data pasta or paste. And one of the nice things that you can do is install some RStudio plugins. So many of the packages allow you for some functionality, but they also enhance the way that you use RStudio. And I'll show you what I mean by that. Once you run these two lines, what it actually does is it adds stuff to these add-ins. And you can see that data paster. So you can paste as a tribal, paste as a data frame, paste as all sorts of different kind of code. So for example, here, because I copy pasted all of that, and I want R to know or have this data inside. So what I can do is I can go over here, and because I installed this data pasta, I can paste this as a tribal. And as you can see over here, it created this tribal. Now, in order for me to make use of this, what I can do is I can create this R script. And in this R script, I can say that I want this X to receive the content of this tribal. So I'm going to do this. And if I paste this like this and I run this, you can see that X actually received the content of what it is that I just copy pasted from that. So you can also very easily copy paste. If you go over here and you want to see what's in X, so actually just like with SPSS or anywhere else, you can go on this environment. There's this little window over here on the right. You click on this window, and then this comes up, and then you can see exactly just like what it is that we saw over here in this CSV or an Excel file or whatever your data set is. So this is a good way for you to copy paste if you need to copy paste for some reason. So that's one of the easy uses. So as you can see, you don't really need to remember anything for that, because once you run that command, let's go back to our magic. Yeah. Once you run these two, actually RStudio is installed with this data pasta, and you can paste this as a vector, as a data frame, whatever it is that you need to use in your RStudio or in R, you can just paste it like that. Another thing that you can do, if you don't have your own data and you just want to do some quick demos, like stuff that we want, there's actually a library, a package that's called datasets that RStudio and R arranged for us so that we can do some quick demonstrations for you. So first you load the datasets, and then you say, which dataset do you want? So actually, this is tooth growth, and I took this from these datasets. So I'm going to ask R to load the dataset of tooth growth for me. So I'm going to push this, and as you can see over here, tooth growth is now installed. And if you open this by clicking on this window over here on the right, you can see that just like what we tried to just import, it imports this already for me. So you have length, you have sub, you have those. Now that we have this data set here, we want to be able to explore it or do things to it. And we have a bunch of functions in R to do that. If you become familiar with R, these are going to be very common for you. So for example, str, like structure. So what is this structure of tooth growth? What's inside? You've got 3 different variables. You've got length, you've got, I don't know, supplement or something like that, or dose. One is a number, one is a factor, and the other one should be a factor, but is a number over here. So we want to try and change this from a number into a factor, because we're worried about this. We want this to be 2 categories in 1 continuous variable. One way to do this is how when I saw this problem and I wanted to do this, this is how I did it. I just decided I'm going to do tooth growth. When you see this $sign, so the $sign actually tells you that you're going to refer to a variable inside tooth growth. So if we go over here, we see columns, length, sub, and dose. And we want to be able to refer to these. So if we go back on the console, and this is a nice thing about RStudio, that it has auto-completion. So if I just punch in tooth growth, it already auto-completes this for me. And if I press tab, it will complete this. And if I press the $sign, it will give me the 3 variables that are in the tooth growth. So because I'm worried about this dose, I can select dose, and then I can say that it should receive something, changing this from a number to a factor. And the way to do this with R is as factor. And once we run this kind of command, I'll show you. If we run this, do Control Enter, and then we run the structure again, you can see that it changed. At the beginning, it was number, factor, number, and now it's number, factor, factor. So we have two categoricals and one continuous. You're probably asking yourself, why am I running piece of code? I want to do this like I used to do this in SPSS. Why is this so complicated? So yeah, there's definitely a way for you to do this that's much easier and simpler than that. And I'm going to show you how to do that. For that, we have, so I'm going to load this again, just the way that it used to be. And you can see that it's number again. So if we install this, it's called question R. So it allows you to do all kinds of manipulation. And it installs an add-in over here that can help you to manipulate question R, levels recording, levels ordering, or numeric range dividing. So let's say that you need to change the type of variable, or you need to recode this into something else. So you have continuous variable and you want to recode that into a categorical variable. You just run these two lines of code, and then it already appears over here because it's installed. It already appears over here. And if you click on this, then I think this looks a little bit more familiar for perhaps what you know from other places like JAMOVI or SPSS. And it allows you to load one of the data sets. So we're talking about tooth growth, right? And we really care about this dose. And we were, because it used to be a character, but now we want to change this into a factor, into a categorical. So we don't want this to treat, because it had the 0.5, 1, and 2. We don't want this to be a numerical. We want this to be treated as categories. So you can actually create a new one, or you can use exactly the old one. You can decide, just like every time you do recoding. So you don't need any lines of code. Plus, you can decide if you want to record this into something else. So let's say that we have these three categories, but we want to combine 1 and 0.5 into the same category. So we can actually recode these here. And the nice thing is that if I press here, code and results, it actually gives me exactly all the code that I need to run. So once again, just my superpower of copy paste, I just take this and I copy this back into my code. I didn't need to even remember anything about how to recode. Plus, it gives me a bunch of checks. So for example, it tells me, you know, you've combined these 20 with this 20 into 1. So you can take all of that, tell it that you're done, go over here, and you can see it pasted all of that for us. Not in a very good location. So yeah, so we'll take all these lines and we'll put them here. So now it's a little bit clearer what was done. And actually, if we run this, run, and we look again at this tooth growth, we'll come back here. We see that it created this dose, recorded, and that it combined everything that was 0.5 and 1 is now 1 in dose that's recorded. So even for data manipulation, something like recording or changing something from a continuous to numerical, it used to be that we needed to remember. So as factor, how do we do this? What do we do this? But now with RStudio, we have these amazing packages and resources that just, we don't need to remember anything aside from, you know, once loading it, and then everything appears in our add-ins over here. So life is good with RStudio. Not like the bad old days where we only had R and had to remember it. Okay, so hopefully this got you a bit more optimistic about R. Let me show you some of the other stuff. So you can see that I've already done this. So I've recorded. You can change things from character to factor. There's a bunch of stuff in here. Sometimes people that use SPSS ask, but what if I want to change some things? So for example, here, if I go to tooth growth and I try to change, I can't change them. This is view only. There's no ability to change this here. It's not very good to change things in SPSS in the actual thing, because that's not reproducible. Nobody knows what it is that you've done. But sometimes you want to do this, and you want an easy way to do this in R without starting to type commands and doing all of that. How to best do that? The best way to do that is it's called data edit R. If you run this kind of library, so you install this, I included this warning. These changes are not reproducible. So it just allows you to tweak tooth growth in order for you to play around with it. But you can go over here and you can see this data edit R, which is exactly the same library here. So if you load this, it will create an add-in here for you, and you can open this over here. And as you can see, as expected, you can do whatever it is that you want here. You can upload one of the data sets. For example, let's load this one, so you can see it has everything that we just saw in the other one. Scroll down. And here it does definitely allow you to change, the variables. So you can change different things, and then you can save it. You can even filter some rows. So for example, you can say I only want, when dose equals 2. So yeah, I can add more filters if I want to, and I can close this. But then it shows only the things that are in those. So then I can save this new data set. So this is just for you if you want to do something that's quick, but you really need to keep in mind that only you know what you did over here, and this is not reproducible. The best way, of course, here would be that you had, the way to save this code, or and there's a way to do that, but we won't go into it. But at least know that just like in SPSS or in JAMOVI, you have the ability to go into your actual data set and tweak things yourself, and then save this in order to load this into your environment. So a bunch of things that you can do. You can save this into a new data set. You can create a subset if you want. So if you run any one of these commands, whatever it is that you edit, whatever it is that you create, will go into the new data set subset. So the only thing that you actually need to know over here is the name of the function. This is the package, this is the function, and this assignment operator, just say the subset gets whatever it is that you now edit from your tooth growth. Not recommended to do things by hand, but if you feel like you want to do things by hand, then there's a way for you to do that. Hopefully no questions so far. Fairly easy and straightforward, right? Nothing too complicated over here. Still a little hard to start. Why? I'll give you some more examples. Hopefully it will give you some more optimism. But now at least we know how to load some data sets. That's the basic thing that we need to do. Another data set that we want to load, we want one data set that is close to t-test ANOVA. That's an experimental data set. So tooth growth is an experimental data set because we have two categorical variables, and then we have a continuous one. A nice correlational data set is big 5. So we'll load the big 5, and the big 5 is this file over here. So it's an SPSS file that includes 5 different factors. So if I load this and I run this, you'll see that it has extroversion, openness, agreeableness. So all these things that we expect from a continuous data set. So you see all these continuous variables that were collected for each one of these big factors. So now that we have all these, we can actually start and play. If you don't have your own data set, R is very, very powerful, and you can do some amazing simulations. I won't show you how to do simulations, because that involves a little bit of code. But if you want to do a simulated data set, there's now a very nice, shiny app that I strongly recommend, that Lisa, I follow her on Twitter, and she does a really cool job by developing this app on how to simulate data for all kinds of data sets. Yeah. So here you can do a 2 within, 3 between, 2, 2, 2. So you can do all kinds of simulations, and then it will load everything. It will even give you like a design plot of what it is that's loaded, so you can simulate your data. It has a bunch of things that you can tweak, cell parameters, distribution. So if you want to simulate data, it's very easy to simulate this using this Shiny app over here, but I won't show you lines of code. Just know that if you want to do simulation, now there's a nice line of Shiny app, a web page that allows you to do that. Now I'll go and show you how R is exactly like SPSS and JAMOVI. The way that I got into R and all of my skills in R, I have to admit that I'm a very lazy R programmer. I have never taken the time to really remember everything. I'm not a pro R programmer. I lack the ability to really go into things in a lot of detail. I'm lazy and I want to achieve results very fast, but I want to be able to do this with R code rather than in JAMOVI or elsewhere or SPSS. And the nice package to do this is called RCommander. And I think this is perhaps going to be the biggest surprise to those who are afraid of R, because it really looks like SPSS and other. So if we just run this library and open this up, so we can load this. Yeah, and this is what comes up. And this already, I think, looks a bit more familiar because it has statistics and it has graphs and it has models and distributions, and it even has something to help us with plotting with ggplot2, which is the most common R package for plotting. So because we already have some data sets, we can load these data sets. So we can set the data set to one of the active ones. So we'll start from tooth growth and we'll choose the tooth growth. And as you can see, it loaded it right now. And if you want, you can actually view it. So it's a bit like a silly interface. Here you can't edit anything, but if you want to edit, you can also edit. RStudio gives you this with RCommander. So you can add a column, add a row. You can actually go in here. Please don't, but you could if you wanted to go in here and change things. The different values. So that's a possibility. Disregard edits, yes, let's not do this. So already you can see that it gives you like point and click within RStudio. And the nice thing is that everything that we're going to do here, it actually gives you the R command that you can copy and paste back into your RStudio. So it's quite amazing. So for example, you can import data. So you once again can import from SPSS, SAS, so everything that you saw in RStudio, actually RCommander gives this to you, and it allows you to do a bunch of things on top of that. So now that we've loaded the tooth growth, we can look at some statistics. So for example, we can summarize all the data that's in tooth growth. I'm gonna narrow this down. So it gives me the command that it ran over here, but the output is actually over here on the bottom, and you can see that length sub dose. It gives me the minimum, the median, the maximum, the mean. So it gives me a bunch of things that I can already, understand what my data looks like. Okay. So I want to do a numerical summary, and I want to summarize length by these two groups. So I want to use sup and dose. Let's say dose to begin with. And then it gives me the command that it's actually running. So it pastes everything in the R code. You can see it over here. And then it gives me all the statistics over here on the bottom. So it gives me all the mean, the standard deviation, the different factors. Other things that I want to show you here, frequency distributions, these two variables. It will give me so how many are there? So there's 20 of this, there's 20 of this. Already pretty good. Anything else that we can do over here? We can run some stuff. For example, we can run an independent samples t-test. So you are already asking, so how do we actually run things on this data set? So let's run this. So I think that sup is actually two categories. So we can compare between these two groups. So this is our IV. This is our DV, independent variable and dependent variable. So we run this, we can include some options, confidence intervals. Do we assume equal variance? Yes or no? the one-sided, the two-sided. Then we can run this, and we can get our result over here. So it ran the t-test, and it gave us this Welsh two-sample t-test. And it gave us the two means and the p-value and everything that we need over here. So RCommander makes things very, very simple for you to run. I think so. If RCommander is not successful in loading, you need to kind of install all these packages over here. Or you can go over here to these packages and install those from here. So the names of the packages are this, but the core one is this one. So basically, you can just copy this here, go to install, do the RCommander, do this run install, and it will install this for you. I think that was the question. And then once it's installed, you can just load it. So first install a package, then load it, and then run the relevant function in order for it to appear. Anything else that we can do over here? We can also run a one-way ANOVA. So we can do, those has 3 categories. So we can run these 3 categories on the dependent variable. We can have an effect size. We can do pairwise comparisons. We can do summary statistics. So a bunch of stuff. And as you can see, it even gives me this very straightforward and easy plot over here to compare the different ones and see if they're overlapping with the 95% confidence level in confidence intervals. And then over here gives me actually the result of the ANOVA. So you can see each factor, the multiple comparisons. So a lot of neat stuff that you can do very easily with a few clicks over here. And as you can see, it actually writes for me what it is that it ran. So I can take this code and put this back into my RStudio, and then I can keep it forever, and I know exactly what it is that I ran. I'm going to do a bunch more. We can do a two-way ANOVA. So for example, we want these 2 factors. We want to include the sample size and so forth. And this is going to be our ANOVA model 2. So we run all of this, and it gives me all of the summary over here of the two-way ANOVA. And here you can see actually also gives me the interaction. So this is only for those. This is only for sub. This is for those sub. And it gives me whether the p-value is significant or not. So you can see this is lower than 0.05. This is lower than 0.05. So the levels of significance plus a bunch of contrasts with the effect sizes of the eta square, the partial eta square. Yeah, so basically everything that I am expecting, plus some post hoc in order to see contrast between different conditions. All right, so this is quite complex. This is, we've done, I think, everything we needed from this. Now we want to plot a little bit, do all sorts of things with plotting. So for example, just with the histogram, we want to see what this looks like. So if we run this, it gives me this nice plot. So I really need to know how to program this because it did this for me. So now, you know, I have the code of how to do this plot. I can even do this plot with plot by groups, and then I can see that it gives me these 3, so I can see the distribution of each one of these together. So a bunch of clicks, very, very easy for me to do this. I can also do, let's see, a plot of means. So let's say I can, what else can I do here? Standard error, standard deviation, confidence interval, whatever it is that I want, how to label the x-axis, the y-axis, all sorts of other things that I might want to do. So this is a pretty nice plot, given that we've actually not coded anything in R. We've just loaded RCommander. Plus, we're able to see exactly all the code in here. Now, the thing that I didn't mention to you yet is that you have the R script on the left. We haven't really talked about R Markdown. What is this R Markdown? This is a good time to kind of like introduce R Markdown to you, because R Markdown is a combination between code that runs and executes, and text. So you can wrap code with a bunch of text. So you can put some text before the code and text after the code, and then you're able to export this to HTML, Word document, a PDF. So let me just show you what that looks like. So everything that we just ran is within these chunks of code. So this is a chunk of code, and it's a code of R, but you can put stuff before that. So for example, here, you can write load library. Here, summarize the tooth growth. Here we did a bunch of other stuff. Here we did a bunch of other summary, and so forth and so forth. Here we ran the t-test. And here we ran the ANOVA. So this is all good and nice. What does this help me? That I'm putting some text between the code, and how is this different from just putting comments? Because we can run this generate report. And when we run this generate report, it actually asks me, you want an HTML, a PDF, a doc? So let's do an HTML. And if I click this as the HTML, it's going to open an HTML for me. It's processing, it's opening. And now you can, of course, call this whatever it is that you want. But as you can see, it has my text, summarize tooth growth, this actual command, and then it gives me the output. So I don't even need to remember. So how do I connect between RCommander and the RStudio? They're a little bit different from one another. I just go to the R Markdown, and then I have everything, what the command was, what the output was. And then if I added something, for example, this text about what it is that I did, it also has this text. I can also export this to something else. I can export this to a doc, Word file. So I'm going to open this as a Word file. It's going to run a little bit. Still running, still running. You can see it's computing 100%. Now it's converting this file. So you can see this RCommander Markdown. Open this and want to see what it actually did. Yeah, so looks pretty good. So we have this, the thing that I actually wrote, and it has all these commands, and it had everything. Plus, if we had some plots, it even gives us the plots within, so we can, use it for our manuscript and just copy paste this. And even if you create tables, actually the tables don't look too bad when it's in Word. So you've got everything that you need. You have the actual command. You can use copy paste if you want to run this again, and then you've got the actual graph for you. Hopefully that looks easy enough, almost as easy as SPSS and JAMOVI and everything else. What else do we have? We have even nicer plots. So ggplot2 is the most common way for us to plot things. So I'll give you some examples. For example, if you want like a violin plot, it has a bunch of things that you can do over here. So let's say, for example, the X variable is length, and let's say I want, by the dose. Then I want this, let's say, a violin plot, and I want some jitter, and you can change it in whatever way you like, no problem. I'm gonna, so we have facet 1, facet 2, we have X, and then we can actually run this. So I feel like we've done enough of the tooth growth, and now we can maybe do one thing with the big 5, like scatter plot. Yeah, we can do agreeableness with extroversion, for example. Yeah, let's see what that looks like. So we create this one by the other. We can also like run a regression and do something with that if you want to. Let me see if there's anything else I want to show you here. Any face-to-face workshops? No, but we can arrange if you want. You tell me what you need, and we can do follow-ups on this. 3 hours every week to learn R. How do I do that? And is it possible? I think it's definitely possible to be certified. 3 hours a week is wonderful. I strongly recommend. 3 hours is above and beyond. Start with Swirl. Take one Coursera that's free, and you can get like credited on that. These graphs can be edited like the color. Yeah, of course. First of all, you can do this with the RCommander because you can, almost everything over here. The font, the color, the graph option. But this is just our RCommander. I'm going to show you other things. This is just like the beginning. Don't worry. There's easier stuff coming up. My interface says no active model. Yeah, so actually you need to select, first you run a model. So for example, if we do tooth growth, for example, here we ran the tooth growth, and we ran what did we run? We ran a two-way ANOVA, right? And we put this into ANOVA 2. So we put ANOVA 2 over here. And once we have ANOVA 2, we can actually do a bunch of other things. So for example, summarize the model. So you can actually see what the result is of that model. So this is kind of like the summary of that model. So yeah, I missed that part. Thanks for reminding me that you need to select the model over here. You pick the model based on the ANOVA or the t-test or what it is that you actually ran. And then all these things about, the hypothesis test, the ANOVA table, the comparison, the diagnostic, the confidence intervals, then everything comes up. So first you run the ANOVA, then you load the model, then this appears over here. Okay, sorry, could you do the first few steps? Yeah, one more time. So first we loaded the tooth growth because this is the one that we're interested in. We pressed OK. Then we went to statistics. We went to the means, and then we ran a multi-way, a two-way ANOVA. So we pressed on this multi-way ANOVA. Here is where we do the model of the name of the model. So this one, I'd say it's called ANOVA model 4, where we choose this factor and this factor, these two factors. You can use control in order to select more than one factor. And then we can say what it is that we want. And then we click OK. When we click OK, actually, we can see that now it's loaded over here. ANOVA model is ANOVA model.4 is loaded over here. And once it's loaded, you can summarize it and you can do a bunch of other things to it. You can compare the coefficient between two different models. Yeah, look at fit, stepwise, confidence intervals, everything else. So that's the basic way of running the ANOVA with this. But I'm going to show you other stuff as well. So don't worry. This is just like one solution. But this is one that's in R. The other things are going to be a little bit more complicated. Yeah, so ANOVA model 4 is what it is. I called it ANOVA model 4. You can call it whatever it is that you want. You can call this HKU workshop. And then once you run the ANOVA model, then you can put it over here and it keeps all the models that you already ran. Okay, so I think we've had enough over here with the RCommander. Just want to say that this R Markdown, we'll come back to R Markdown, but R Markdown is like the easiest way to follow and comment on everything that you did. So like the Jupyter notebooks, you can just like punch in whatever it is that they call and then save this and come back to this afterwards. And of course, each one of those, you can go create an R Markdown file and then untitled. Yeah, so this creates another R Markdown, and then you can like copy paste everything into this R Markdown and run this yourself. I'm going to come back to this on how to run R Markdown in RStudio yourselves, but this kind of summarizes the RCommander file. So I don't want to spend too much time because it's just one solution. Let me show you another solution. Perhaps it will be easier. You asked about colors, how to change colors, how to do all sorts of things. Another solution is this one. So you can run this, you can install this. By the way, if something is commented and you can't run it, so if I just go on, on this line and I do run, it doesn't run this. I need to, of course, remove the comment, then it becomes a line, and then I install this. And once I don't need to install it anymore, because you only need to install once, I comment this out. Plus, you can, of course, always copy here and paste this in the console. And if I do this over here, it asks me, do you want to restart? I don't want to restart. And then it will install this, but it will tell me that it can't do this because it's already in the system library, loading it. After I load this once, I can go into the add-in, and then I can see this wonderful package, ggplot2 builder. So I can press on this, and something comes up. And this already looks, very appealing because it has a bunch of, point and click. So I can choose the tooth growth, can load this in like my general environment, and I can import this data. I can also view or update, so I can see that this is exactly what it is that I wanted to work on. I can also update all sorts of things. So if it wasn't a numerical and I wanted to change it into something else, so this interface allows me already to import the data sets, change all sorts of things, manipulate some of the content, plus allows me to start plotting things. So for example, it automatically, once I say that the length is the X variable, I just dragged it from here to here, and it gave me this, this nice plot. If I want to do this by different facets, groups, so let's say, for example, I want to do the stop here. So it already, gives me these two, the OJ and the VC, the different one. You can do a box plot, but you have many other things that you can do. You can also change this into a violin plot. You can change it into whatever it is that you feel is appropriate, or you can let it do automatically what it is that it recommends. Plus, let's put those here and then supplement like the facets. Yeah. So it can feel the color and everything based on the different variables, but already you can see just with me dragging and moving this around, it already gives me some pretty nice plots here that I can use in order to import. And the question is, what can I change? I can change basically everything. I can use a different colors over here. I can change the, whatever it is that I want, the number of columns, the scales, the X and the Y. I can change the labels. So I can really make this very pretty because it, ggplot2 is very powerful. I can also like manipulate, all sorts of things regarding what it is that I'm looking at. And at the end, look at this. Here you have just the code. So this is wonderful. We can just like copy this to our clipboard and then go over here into our main window and paste it over there. So that's wonderful. Copy and paste. You can even right here insert this into the script. And it will insert this into the script. So all this is with this wonderful plugin for RStudio. I don't even know how to pronounce this, but this is just to show you that you don't need to be, a code expert to do a ggplot. So sometimes I see all kinds of bad plots in articles or students that are submitting all sorts of very basic ones, which is understandable because it's very difficult to understand which factor in every, but now you don't need to because you have other ways of doing this a lot simpler with all kinds of add-ins. As you can see, I did not write one line of code to do any of these plots. RCommander is one thing, and this one is a different package. This package you only need to load once, and then it appears as an add-in. Over here, you can go into this Esquisse and do this ggplot2 builder, and then you can even export this to the PowerPoint. All you need to do is once you have your tooth growth or you have your own data set loaded, all you need to do is go to the add-in and then run this ggplot2 builder. And then it will give you some really nice plots. Yeah, how to call the RCommander? This is the RCommander code. Everything is here. I didn't change anything. Everything that I did is actually in here. If you want to install all of that, you just go here. The way that I do this, you can't see this, but it's a Control Shift and C. So this comments this in and out. So I can just uncomment it, run these lines of code, and then I can just load them with these libraries, and then it should come up. Sometimes it doesn't come up because it's like in the background, so sometimes you'll need to like close it and see where it is, just like happened to me here. So just look for it. It should be there. It should be loaded. But yeah, we'll say goodbye to our RCommander for now. Or do you want to exit? Yes, I want to exit. Do you want to save the script file? You can actually save both the R and the R Markdown, but we don't want to save either one of those, so we're going to skip that. Yeah, try my script later. Should be okay. But everything in this workshop, you can actually email me later. If you're a student that's taking one of my courses, of course, you can write to me on Slack. Very happy to help you. Whatever it is, email, Slack, Twitter, Very happy to help you. As you can see, everything is so simple. Like I haven't even done anything. I didn't even write lines of code. I just go one by one, load packages, and then just drag and drop. So these packages can be found on the internet. Not only can they be found on the internet, they're completely open source. You can even like, it's everything that's RStudio, all these packages, everything is open source, everything is active development. You can even get like help and support. If you find a mistake, an issue, you can open an issue on GitHub and get the developers to help you. I do this all the time, even with JAMOVI. I go on the packages GitHub. So here, for example, you can see that this one is developed here. That's why I included this address. So you can go over here and talk to the developer. So let's say that you found a problem, or you want to have some request for them to add something. So you just go on this address. First of all, it tells you how to install. It takes everything from the internet. It gives you even a demonstration of how to do this. So you just drag and drop, how to use all the functionality, and then how to get the code out. So even if you don't remember what it is that I did, every time you just look these things up, it will give you a very, very simple step-by-step on how to do this. How did I open this? I went to add-in, and then here I was just looking for, you know, A, B, C, D, E, F, G. So E, Esquisse, and then the ggplot2 builder. This is how I did this. So pretty straightforward stuff. I just want to show you that you can communicate. So if you want to open an issue, if you have a bug, everything is community. We're all helping one another. The open source is an inspiration for the open science movement, so we can all help one another. So actually, you can report issues, and they're very responsive. The ones that are in active development, they can give you a solution within a few hours to a few days. So every time I reported something, if it's very urgent, it was treated very fast, especially with the JAMOVI folks who were amazing. Yeah, good question, Jing. Yeah, so I guess you mean this. So the RCommander, the name of the package is RCMDR. But inside this package, there are a lot of functions. One of the function is called commander. So this is the name of the function. This is the name of the package. So it makes the association between the function and the name of the package. So for example, here, we can look it up in the help. So we can go to the help over here. We can look at commander, and it will give us. So this is an RCommander, and it actually starts the RCommander GUI, the graphical user interface. So the only thing that it does, it calls this function in this package. Have I recorded this workshop? Can I have access to it? Just, yeah, of course. First of all, you can go and use this. You can scan this or go in this cloud folder. So mgto.org/R workshop. Plus everything that I do, both in my courses and my workshops and my talks, is uploaded to YouTube. So you're very welcome to go and visit us on YouTube. I showed this before. So let's show this again, YouTube. Can just look me up, Gilad Feldman, and yeah, it's up over here. There's some playlists, and this is going to appear in the workshops. If you can't find us, you can just like Google me, and then you know, one of the things that comes up is this YouTube channel over here. So if you click on here, you'll get to my channel, and everything, including this one, is going to be posted on that afterwards. So don't need to worry. If you want to come back and revisit any of this, no problem. Please do share and do whatever you want with us. It's all for you. Plus, if you want, there's some other workshops as well. So for example, how to do pre-registrations or register reports, or if you're interested in JAMOVI, I'm going to touch on JAMOVI very briefly in a few moments. But yeah, want to do open science, everything is on YouTube. Plus, there is also an OSF of all the talks. So every talk that I ever gave in workshop is also on the Open Science Framework. So you can also Google that. So everything is available, including all of my slides and all of the videos. So everything is open and shared. Yeah, since somebody asked about the YouTube video, perhaps it's a good opportunity for me to tell you that, actually you can, so how do you get here? You can actually Google me. And if you go on the main page, so it's here under my name, so it's mgto.org. If you click on this and go to my website, I wanted to show you a few things that you might find useful. So for example, here, it's called the Mass Replication and Extensions Effort. So every student that's working with me knows this very well. But it's a very big project that I'm doing with early career researchers and my students, early career researchers from all over the world. There's quite a team involved, and we've done some stuff. So if you want to know more about that, there's a YouTube video where I talk about these things. The reason why I'm mentioning this right now is because actually there's lots of resources here for you. So we do a lot of collaborative stuff. If you want to find my teaching materials or my workshop materials, or you want to see who is in the project, or you want to see all the projects that students have done with me, we've completed about 100 of these replications and extensions or RR assessments. You're welcome to do this. But the thing that I really wanted to show you are all these guides. So we've developed guides. We write them collaboratively. Each one of you who comes in, if you contribute and you add your name as a contributor, and it's a meaningful contribution to these guides, and we submit these guides finally to a journal, then you become a co-author. So everything in the open science community, we try to share and give credit. So I'll show you some of these guides. The guide that is more relevant to you now is this guide. It's the R RMarkdown collaborative guide. You can go and look at this over here. It's mgto.org/markdown guide, which will bring you here. Same guide over here. And you can see that just like in the cloud folder, there's actually a lot of information over here. So how to get started with R and RStudio, a lot of resources. Why should you choose R? How to get help on R? How do you install R? The quick how-to video. So all of these are links that will take you to other places, a list of terrific videos about everything in R, a lot of guides. So I mentioned Swirl. If you want to know more about how to get started with Swirl, and a YouTube video that's showing you how to do stuff with a Swirl. Lots of books. So every time I see an open book about stats with R or something about R or how to plot with R, I add those here. So all of us are coming together in order to, if you need to take courses in R, get accreditation in R, some workshops that I've seen people on Twitter post on R, some communities of R. Plus, after you get through all these resources, and there's lots of those, there's also some helpful suggestions on how to do things. For example, I showed you how to do loading datasets. It's quite easy with RStudio and RCommander, but if you want more information, there's some cheat sheets, some videos to show you how to do this kind of, some books to help you with this, how to do data manipulation, how to do outlier detection, using the tidyverse, how to visualize all sorts of things. I'll show you the ggstatsplot, but there's a lot of things in here. So it's basically all of us together are updating this in order to make sure that whatever it is that you do, mediation, moderation, SCM, HLM, multiverse, whatever it is, there's a bunch of links here for you. So if you want to get started on R, but you're not sure what the resource is, of course you can Google this, but sometimes there's so many things on Google, it's hard to find those. You can go on this collaborative guide and find what it is that you're looking for. Plus, if you want to know more about R Markdown and how to do things in a more reproducible way, so there's lots of guides and templates and things that you can look into here, even some code snippets. So to get to these, I just recommend you go on my website, you go to Mass Replications and Extensions, and then you just go, there's one button here that says Resources. When you get to the resources, one of those is the collaborative R Markdown guide, and it's mgto.org RRMarkdown guide. So even if you can't follow or catch the exact link, everything is on my website. So just know how to find these in order to let me see. Okay, so I've shown you the R Markdown. Also, if you're in my courses, you're probably using JAMOVI. If you're at HKU, you're using JAMOVI. Some people like JASP. So if you need more resources on how to do things in JAMOVI, JAMOVI now is a very active community. So you've got a bunch of books and videos and guides. If you need help with anything from multi-level on how to do pairwise chi-square or whatnot, there's all sorts of helpful things for you to use over here, plus a little bit about JASP, all the videos and the books, and we try to keep this up to date. I don't know if you're familiar with this, but if you're still for some reason using SPSS, then SPSS costs money. I wonder if you know that there's an alternative, open source, completely free alternative to SPSS that does everything that SPSS does. Did you know about that? Yeah, so let me show you what that looks like. PSPP instead of SPSS is how I run SPSS stuff. I'm tired of licenses and having to connect to HKU VPN every time. And this looks exactly like SPSS, only it's open source and completely free. It doesn't have all the more advanced capabilities, but it definitely has the basic stuff that SPSS has. So at least support the open science community instead of IBM. So you have that. The other thing that I wanted to show you, and this is where we're going to continue now, I'm going to show you Statscloud. So this is the main one that I wanted to show you because I think that's a real revolution. And it does also everything with R. So we're going to open this together and see what that looks like. It's in beta, but it's improving super fast. Like every month, they're adding some really exciting stuff. I really like this team and how fast they're working to deliver this amazing thing. So you can see it's a web app everywhere, and it has the ability to import or take this from a Google Drive or whatever. So we're going to import from our directory over here. We're gonna import again this tooth growth. Yeah, but it's not exactly what it should be. So we can manipulate this and manipulate this. So we can write the name of the variable. You can see the interface is very easy. And this is doth. Goes here. And then we can delete this row. Let's delete this row. So now we have everything organized well. Actually, we don't really need this one, but it's okay. We can go and manipulate these over here. So if we want, we can actually delete this one, but let's keep it. Let's leave it over here. So we've imported tooth growth into this Statscloud app beta, and it already allows me all kinds of really interesting stuff. I'll just show you some of it. First of all, just move this one over here. Yeah. First of all, if you go to you can of course manipulate this in place. You can do whatever it is that you typically do when you look at stuff at JAMOVI or SPSS. But it's really nice because you compare all sorts of data. You can compare the mean, the standard deviation. You can add a group by a certain variable. So you have some very easy descriptives, and you can of course copy and save these. Already here below, you have the mean of all of that. So length, just by pressing this over here, pressing this length over here, I can see a summary of the mean, of everything else, the counts, the mean, the max. I can see, assumptions of normality. I can look at the frequencies. I can look at the centrality. I can even detect outliers and see if I want to, do some filtering based on that, based on the deviation from the mean or the median. I can transform all sorts of things. So I can, for example, see what happens if I do all kinds of different transformations. So if it's not normally distributed, then I can play around with this. And every time I play around with this, it will give me the skewness and the contours. So This is really stats on steroids. It's I don't think I've ever seen an interface as friendly as this. So really exceptional job by these folks. Really well done. Plus, they will flag stuff for you if something, they don't know that this is categorical, so they flag this here. Actually, we need to change this into something that's categorical. So once again, it's as a number, but we're going to shift this into a category, and automatically it sees all these categories. I'm actually going to delete this variable because we don't need it here. But once again, we have these two categoricals and one continuous, and we're going to run some ANOVAs on that. Now, we can do also some filtering. So can do whatever it is, you know, exclude or include. Length is equal to enter a number. So if you want, you can, let's say, those is equal to 2, and then you can you know, use this filter or not use this filter, and then you can go back to the data and see how this is actually you know, applied on that, yes or no. You can add another filter. So whatever you want, you can, you know, add it here. My filter, code this. So very easy interface. So the reason why I'm showing you this whole thing is because there's an export to R. So if you press on code here at the end, you can just do, you know, our favorite copy paste. You can just like take this whole thing, copy the code, download the file, and move this to your RStudio. So the reason why I'm showing you this tool is not because like there's another tool that you can use and it's not related to R. This is R. It gives you R. So whatever you do here, you can just take it, you know, with you to R and work on it over there. But at least the heavy steps of, you know, importing, manipulating, filtering, everything you can just take with you, and it gives you everything in R commands, which is quite exciting. I haven't seen anything quite as easy as this before. So try this and play with this and see how you can import from Statscloud to your own environment. Just copy the code, include this here, and do that. The other thing I wanted to show you is JAMOVI. You're familiar with JAMOVI, but a lot of people actually don't know that JAMOVI runs on R and can be imported to R. I'm going to show you how. I'm going to open JAMOVI, hoping that my computer is not going to crash. So there's going to be a cloud version that you'll be able to run on the web. I think there's already one, but maybe it doesn't allow you to do all the. Let's see, it should be JAMOVI Cloud somewhere. Yeah, Cloud JAMOVI. Hopefully, it will have like all the functionality. But yeah, at least for the very basic stuff, you'll be able to include this and then move the stuff to R. I'll show you how. So, for example, this is from the cloud, so you don't even need to you know, download this. You can just like run everything over there. By the way, since I'm showing you stuff from the cloud, I can also show you that there's a cloud version of RStudio. So if something that I showed you here doesn't work very well for you because, I don't know, Mac or whatever, I don't have a Mac, so I don't really know, you can also run RStudio with online. So you can get started for free. I think it already loads to my project. So there's like a bunch of projects. So actually you can, you know, resume whatever, you can share this with whoever. So both RStudio and R and JAMOVI have cloud versions now. So even if for some reason it doesn't download for you, so yeah, as you can see, you can open all sorts of things. Here's a famous tooth growth. And what I wanted to show you, and I think a lot of people don't actually know this, is here when you open these 3 dots over here on the top right, it has something called syntax mode. And whenever you do syntax mode, let me just show you, for example, we want to do descriptives. So we want to see this tooth growth. So we're going to import length split by these two. We want to do some interesting plots. So let's do violent plots and the mean and all that. So we really like these kinds of plots and we really like this kind of thing. So we want to be able to just like copy paste this, the commands. Everything runs on R. So we're going to, this is actually R. So you can copy this here. how do you open the descriptives window? Exploration descriptives. It's over here. So yeah, each one of those is like has a drop down. So exploration, descriptives, opens the descriptives. I'm just assuming that many of you know JAMOVI, but if not, of course, just like download this and play with this. JAMOVI is amazing. So this is actually R code, and you can copy this syntax, and then you can just like go over here. And if you run this library, it's called JMV, and you run this descriptive, so you just make sure the tooth growth is imported into your data, and then you can run the descriptives over here as well. And you can see that you get exactly the same kind of table and the same kind of plot, I think just a little bit misaligned, that you did over here. So very easy. Instead of having to think of all the commands in R, in the RStudio, how do I do this? How do I do that? Don't need to remember anything. Just do this in JAMOVI and then import this back into your R. Can run even, why doesn't it have, here's the ANOVA. So we can run like an ANOVA, very easily do these here. We can do, you know, an effect size, and we can do post hoc effects and a bunch of things. And then we want coherence D and a confidence interval. This is some very elaborate stuff to run in RStudio, but because we have this amazing command in R, so basically it gives me everything that I need. I can just copy this, go over here, paste this to do a t-test or to do an ANOVA, and it just runs. So the same kind of thing that I would run, let's say with it, I think I already did the t-test. So we can do a simple t-test on the dependent variable. The sub is a grouping, confidence intervals, descriptives, and plots. I can just like take this whole thing, copy, and then go paste this before with my desktop one. And as you can see, it gives me exactly the same thing. Now, I didn't show you plots before, but actually most of the plots appear here. And if you want to zoom into them, you can. You just, you need to open this, and then you can move between them back and forth, back and forth. And then you can zoom, you can export this into an image or a PDF. So everything that you run over here, instead of, you know, saving it or appearing in the console, it appears over here very easily on the right. So actually, yes, you can use JAMOVI instead of RCommander. It gives you, RCommander gives you a bit more if you want to do data manipulation or if you want to do more elaborate stuff. But you have RCommander, you have Esquisse in order to plot. Then you have the Statscloud that crashed on me, but usually it works really well. And then you have JAMOVI, and all of these are terrific, amazing, running on R, exporting to R solutions that you don't need to remember everything by heart. You don't even need to know how to code. You need to know how to copy paste. So yeah, can you change the design in JAMOVI? Yeah, you can do a bunch of stuff. Yeah, I'm going to go away from this one. I'm going to open this on my desktop. You'll see that I have a lot more options in my desktop than I do online. But if you don't have them for some reason, I don't know why, you can run this on the cloud. Everything you can run on the cloud. So now I'm going to open the tooth growth again. See, if you want, there's a whole workshop, a 3-hour workshop on JAMOVI that I gave, and that's available on the YouTube. So we have a bunch of things that we can do over here. We wanted to do an ANOVA. The one thing that I wanted to show you is actually you can do some really easy plotting. So for example, this flex plot is a very easy way to just very easily, I just drag stuff and then, it updates automatically, right? So you can do that. So every kind of manipulation, at least from the basic things in JAMOVI, you can immediately import those into your JAMOVI. The other thing that I wanted to show you is that actually, how do I know that JAMOVI runs on R? So first of all, we can change here and do syntax mode. So everything has R underneath. Plus, there's this window. It's called RJ editor. So we can open this RJ editor. So if there's something actually that you've done in R, but you want this to run in JAMOVI, you can do this. You can actually an R snippet into R and do this over here. So I'll give you an example. I'm going to run the library of GMV and GMV connect, and it connects between the RStudio and the JAMOVI so that they can work with one another. When I go to this RJ editor, the only thing I need to change over here is instead of using the JAMOVI R, I'm going to tell it use my system R, and now they can really talk to each other. So, for example, I can run a bunch of things. So, for example, I can run this ggstatsplot. Let me just like load it first. Let me see if that works okay. Yeah. So it just took a bit of time to load, but you can see that actually I can run stuff from a package that is loaded in my RStudio. I can actually run this here. So it gives me the actual R command, and then it runs it inside JAMOVI on my data in JAMOVI. So actually it runs it on whatever is here, it runs R on it. So, you know, if you're too afraid of RStudio, but you want to run the power of R, you can do this in JAMOVI by having both of them talk to each other. So every time I click on this R box over here, I can actually change this line of code and I can adapt the ggstatsplot. Luckily, at least for the ggstatsplot, recently JAMOVI included ggstatsplot, which is actually does ggstatsplot on its own. So you can see that it has this graphs and plots. Yeah. So we can actually have an interface now for that. So we can run these things together much more easily. But I just want to show you that you get the same kind of result when you import this from R. And if you actually run this with the wrapper that's inside the JAMOVI. Question is, I've installed, yeah, I'll show you in a second. Yeah, so as you can see over here, it like runs all of these analysis and will give you, oh yeah, the final plot of comparing all the doses. Now the question was, how come I have all these amazing things up here, but you don't? It's because I went to this big plus sign called modules, and I clicked on it, and I went into the JAMOVI library, and I clicked on that, and then it tells me all the stuff that's available. So for example, RJ editor, if you want to run R code inside JAMOVI, you go over here and you press install. If you want to run ggstatsplot, so you go over here and you do ggstatsplot, a wrapper for ggstatsplot. So it has amazing things in there. JAMOVI is very, very powerful now. You can even do a meta-analysis or a path analysis or moderation, mediation, flexplot. So that's the reason why at HKU we moved completely to JAMOVI, no more SPSS. Hopefully, as a step towards R. But this is just to show you that if you thought JAMOVI is not related to R, JAMOVI is R. And actually, you can use the power of JAMOVI in R, and you can use the power of R in JAMOVI. They're actually together, which is why I like JAMOVI very much. So basically here, we're using these packages. So this is the JAMOVI package, and this is the function that we imported from JAMOVI. The only thing that you need to do in order to connect between these two is this line of code. The only problem is that JAMOVI expects the data to be called data. So if you're trying to do this on tooth growth, you load tooth growth, and then you just import tooth growth into data. That's the only thing that you need to do in order to use the JAMOVI functions on your actual thing in RStudio. That's the only conversion. The actual data needs to be called data. That's the only thing that you need to do. So you load the tooth growth, you load these libraries, and then you run, and it gives you these wonderful things. So well done, JAMOVI, for giving us these very powerful things for copy paste of syntax. You don't really need to know much more than that. So that's yeah. So that was JAMOVI. Of course, you can do this with like different data sets. So for example, we talked about the big five. So in the big five, we have a bunch of other remarkable things. So for example, we can do correlation matrix, get all these together, import them, flag significant, add confidence intervals, do a correlation matrix, add statistics, all these wonderful things. I did, 5 clicks maybe, gave me all these amazing outputs that didn't take me any time, giving me all these results. And now all I need to do, go here, do syntax mode, copy this, and then I can run this in my RStudio. I can run this. The only thing that I need to do is data equals big 5, which is what I loaded from before. So it then knows, run the correlation matrix on data, which is actually big 5. That's the only thing I need to do. I go on JAMOVI, press a bunch of clicks, go to syntax mode, copy paste, put it in the RStudio, and that's it. I have an amazing R that runs everything with all the power of R. So that's how easy things are with R. Really remarkable. So I guess there's some advantage of sitting and programming everything and knowing by heart every line of code, but really no need, especially if you're like an undergraduate and you're trying to get stuff. You want to explore very, very fast. This is the way to do it. Yeah. One more thing I wanted to show you, just to show you that there's even more than this. Also a new tool, it's in beta, it's called Statsnotebook. Let me show you. You can download this to your PC. Statsnotebook. It's completely free, open source, reproducible, powerful, all of the above. You go here, you go download. It's 1 GB. It's huge because it includes all the R in it. And there's some tutorials. I'll show you what this looks like. I'm completely blown away by this thing. Very, very impressed by these folks. So it's called Notebook. I'll try and open this. Hope that everything is going to be okay. So this is new to me too. I saw them on Twitter for a while, but I was planning for this workshop to kind of take a look at them. But you can see, just as I open this is already, it runs on R. It gives me everything. It already analyzes all the libraries, and it tells me everything that it does on R. So that's remarkable. I'm going to open our favorite thing, so SPSS, whatever. Let's open our tooth growth again. I'm going to go here, open our tooth growth, because that's what we used so far. So all this is very familiar to you. You have length and sup and dose and everything. And now you can easily, first of all, you can already see it sets the working directory. It loads the haven. It reads the SPSS. So you have the code. You just copy paste this back to your RStudio. Then you go to data, and you can manipulate the data. You can play around with it. You can do new variables, compute, whatever it is that you do over here. So for example, if you do len2, and you do that this is equal, I don't know, let's say the log of length. So it already knows how to do this, and then it says code and run. So I'm going to do code and run, and it runs this. And now you can see, if we go back to the data, there's length too. And it gives me the actual code, the R code. You just copy paste this back to the RStudio, and it's all done. You don't even need to remember how to do this, because you have this amazing interface that's here. If you want to do some filtering, you want to do recoding, you can do recoding, for example, length recoded, and then the new value for this, the condition is, let's say, if this is lower than 10, then it's 1, something like that. And then you add the rule, you run the code, you ran the code over here, and it gives you the code that they are. You already ran this, so you can go back to your data and you can see the recorded, which is remarkable. So it's got everything for you. You don't even need to remember what is the R syntax. So that's terrific. How about analysis? Does it know how to do ANOVAs and plotting? Yes. Descriptive statistics. It gives you these these variables, so you can put this here. You can split this by the dose and by the sup. And maybe run some, I don't know how good the plots here. I haven't played with this, but let's run stuff. Why not? Let's see how far this goes as the beta. But yeah, it gives me all the analysis. So it tells me what it loaded. It gives me how it did stuff to the current data set. It gives me the ggplot syntax, so I don't need to remember anything. And then it gives me the outcome. So you can see all the outcomes here. So quite remarkable. Now it kind of does everything for you. It also runs, let's run in ANOVA. Let's see how this works. So the outcome is length, the dose, and the sub is here. And I'm going to add, let's say, the interaction. I'm going to add this here. Great, code and run over here. So it's analysis, run this over here, and it gives me all the code, it gives me all the output, it gives me all the ANOVA. You can keep playing with this data, the way to visualize things. So length, yeah, you can run with this. It's better. They're working on it. I guess at some point, like JAMOVI, hopefully they'll have like an online version. Because everything runs on R, it's really easy to import this to everything else. I'm very hopeful with this group. They're doing a lot of progress very fast. But this is only to show you, you don't need to remember commands. You just need to know how to do copy paste. There's some amazing tools. So even if one thing doesn't work for you, let's say on Mac, between the RCommander, the Esquisse, the Statscloud, the JAMOVI, and Statsnotebook, all of these together, one of these solutions should work for you. So I hope that gives you some hope that between all of these, you can find something. Check the newest version on JAMOVI works on Mac. Yeah, it should work on Mac. Okay, we've seen some dialog boxes and all that. I also want to show you that even if you need to write some code, actually the code is really easy. So if you go to this ggstatsplot, actually we can look this up, so we can see all the kind of like vignettes and the way that we can use ggstatsplot. And within one line of code, you can run some really powerful stuff. There's a way to start. So if you need violin plots, histograms, dots, scatter plot, correlation matrices, you have different functions that do this for you within one line of code. So for example, if you load ggstatsplot, you can run, this is for example for a between subject design ANOVA on tooth growth. So we have, for example, dose. So if I just run this over here, so you can see that over here on the right, it should have my, it's a little bit slow, but after a while, it comes up with this. And I'm going to open this just to show you how amazing ggstatsplot is, because what it gives me in one plot is not only just the violin plot and the jitter dot, and the means, and for each category. It also gives me the actual ANOVA, so the Welsh, the F, the p-value of the differences between the number of observations. So the level of detail that you get from one line of code of ggstatsplot is unbelievable. It's just like I have never seen anything like it. So I remember the time where, to get ggplot2 to give me some kind of violin plot was endless, code. I needed to look up and what is this attribute and what that is attribute. So here the only thing is, what is your data set? It's tooth growth. What is your X? It's dose. What is your Y? It's length. What is the title? Tooth growth. And that's it. Gives you this amazing thing. And then of course you can export this as an image or a PDF. So even if you don't want the click dialog, or I don't know, you're on Mac and you don't have the other, there's other options for you, because these packages are so powerful that within one line of code, you load this, and then you simply take this and import, whatever it is that your data set, and run this. And actually, as you type this, so I can show you, it actually gives me almost everything. So it opens all the functions that are within ggstatsplot, so I can choose the one that works for me. And then I open this, and as I start typing, it tells me exactly what I need to do. So for example, I can do big 5. So everything is autocomplete, and it's very easy for me to write this. But we can use just our superpower of copy paste by going to the examples over here. So all the vignettes, there's a big example of all the vignettes. So between design, within design, histogram, very easily go over here, see what the code is. So for example, take this code, it shows you exactly what it looks like. And then if you want to tweak it, if you don't want these p-values of what is significant between the differences between them, you can remove it. There's all sorts of things that you can add. So you can see all the options here. You don't need to put all these options, but if you want to change the x-axis or the y-axis, or if you want to remove outliers, or if you want to change the way that it looks, you can do all of that. You don't have to, but you can if you want to. Just go on the ggstatsplot website and see how to do this. Can we have a copy of today's script? Yeah, it's in the cloud folder. So if we go back over here, the cloud folder is this, https://mgto.org R workshop. And if you go on the, so it's this R workshop, MGTO. And then you go over here in the R workshop, it's under code. Plus, after the workshop, I will send you an email with links to everything. So you don't even need to remember this if you lost track of everything. So that's ggstatsplot. Super easy and comfortable. Good life. Didn't have this 5 years ago. This is remarkable. Now I want to show you how to do descriptors. So you think that was easy? Let me show you something that's even easier. Like one line of code creates an entire report for you. So traditionally, when I started with R, this is what we had. We had the psych library. So we wanted to see what is tooth growth. So we loaded the psych library and then we did describe. Like, okay, this is a good start and it gives me some stuff, but I want this to be much more detailed. I want to know if this is, normality, and I want to see whether there are outliers, and I want to see all sorts of other things. Now we have Dataexplorer, and Dataexplorer is amazing. So let's just load this and create a report. And I want to show you how detailed this report is. So instead of you having to think, wait, what do I need to check? I need to check this, I need to check that. Dataexplorer basically just loads everything for you. So let's do this. Like load the library of Dataexplorer, create report. It's going to take a while, but then it creates an R Markdown. It creates a whole report, a PDF that includes everything that I need in order to know everything that I need to know about tooth growth. So you can see it's thinking, it's loading all sorts of things, lots of plots. It's working in the background, and finally at the end, this is what we're going to get. What are we going to get? Yes, and a complete report. Basic statistics, raw counts, everything about how the distribution of all the variables, the data structure. So we have the length and the stop and the dose, and you can even go further if is there any missing data. Luckily in our data set there isn't missing data, but maybe if you got something from Qualtrics or you've got your own data set, you want to see if there are missing values, you should check for missing data. You can have this in your report with one line of code. Look at the distribution. You don't need to even put anything in JAMOVI and drag and drop. It gives you the distribution of each one of these variables. It gives you all the distribution of all the frequency, the QQ plot. It gives you even a correlation analysis of all the variables. It does some factor analysis, a complete report for everything that you need to know. Do you like this? There's another one. It's called dlookr. So we can load this and let's do a diagnosis report. Let's diagnose to see what's happening with tooth growth. Is everything as it should be? Let's open this up and see what's happening. So this is a PDF. One line of code, created all of this. Data quality, diagnosis report, content. It just opened. Diagnose data, list of all the variables and their quality, missing, unique, diagnosis of categorical variables, has everything that I need to, and plus APA kind of tables that I can use. It diagnoses outliers. So do I need outliers? Don't need outliers? All this with one line of code. There's another kind of report. It's called either a web report. Let's do the web report. If it doesn't run for you, it's because you haven't installed the stuff that's needed for R Markdown, because this is based on R Markdown, and I'll show you in a bit. Yeah, okay, so we have a web report, an overview of our big five, all the univariate analysis of the, all the big five factors, a normality test, a bivariate analysis. So remarkable. I just ran one line of code and it gave me all these amazing things. Here, this text, the text thing, it's mictext. This is the one thing that you need to install, and you can go download the mictext. And this getting mictext, installing this on Windows, or I don't know what it is to your platform, but you can go over here, install this, and this goes together with RStudio in order to take the output of R Markdown and export this to a PDF or a web or anything else. So that's one of the components that you need in order to run the R Markdown. I deliberately used the biggest, highest level, most abstract function. They have sub-functions, so you don't have to run everything together. You can run sub-functions of that. If you have a big data set or you have a lot of variables, it's going to take a while, and it's going to be a very big report. And you can use specific things in the function in order to do this about specific columns. For each one of those, if you want to know more about this, you can just you can look it up by doing a question mark or just typing it here. Also go to the actual development website. You don't have to look at the issues, but you can look at the documentation. And then it gives you how to install this, how to use this, the kind of diagnosis. So you can do like more simple commands, like for example, dim on some of the data set and not all the data set. You can, of course, run this on all the data set, but you can use it on a subset of the data set. It's really up to you. But I just wanted to show you the power of how in one command you can do this for the entire one. So for example, you can do diagnose only on the column flights, year, month, and day, and not of all the columns in your data set. So yeah, everything in R is very, you've got a lot of options. Plus later, when you learn with Swirl, you learn how to do the tidyverse, you'll be able to understand how to manipulate these things. But that's more advanced. I just wanted to give you a teaser so that you'll understand the power of R. There are also lots of projects that I kind of follow on Twitter, people that work very hard in order to provide us with very powerful packages for R. So let's put all the JAMOVI and the RCommander and all the powerful platforms and solutions aside. Let's say that we actually want to get into doing some stats. One of the promising things that I really like recently that I saw is this easystats, or some people refer to this as the easyverse. So you can load the easystats, and then you can very easily do some pretty neat stuff. So it gives you already everything, the R, the confidence intervals. So basically with one line of code, correlation of the big five data set. So looking at all of these, extroversion, openness, agreeableness, putting them all together and contrasting them against each other with a correlation. So one line of correlation actually does all of the columns in the big five together. Also summarize this for us. It's kind of like a plot in order to see where all the all the different ones are. Yeah, so you can open this and have a look at this and then analyze this. So you have a bunch of them. Okay. Plus in ANOVA, this is a little bit more complicated, but let's say that you created this with RCommander or you created this with something else. This is the most common way to run in ANOVA, and you put this into the model, if you remember the models from RCommander. So if you do this, actually easystats already gives you the confidence intervals very easily for the eta square. So that's really nice. It also gives you like a plot of the estimated means. So you can see it gives you all this with very easy. So plot and the model. So that's fantastic. And then plus, and I really like this feature, is that you can do a report. So please report this model. How to report this model? You can copy paste this to your manuscript. The main effect of SUP is statistically significant and large. So actually, it gives you everything that you need. You just copy paste this, put this into your manuscript. I don't like to use the statistically significant language, but if this is what's going on in your courses, that's fine. For me, the most important thing is the effect size and the confidence intervals, but already you can take this, copy paste this to your manuscript, and you've got everything. So within one line of code, report model, it gives me everything that I needed. I'm curious if it actually runs on the report. Yeah, so even the stuff that we ran from RCommander, it gives us everything that we need to know in order to make sense of this. All this is ready, including the interaction, including everything, including all the p-values and the confidence intervals. So a lot of the students in my course are struggling with how do you compute effect size? How do you compute confidence intervals? And it's complicated, but then you've got easystats or the easyverse that allows you to just do report in the model, and then it gives you everything, which is a good time for me to say that one of our guides is available to you to come and have a look. So we have a guide on how to compute effect size and confidence intervals. It's under heavy development by Chinyu, who does an amazing job at keeping this up. So if you want to know what effect sizes are, so for example, he summarized all the effect sizes, let's say by Cohen, or the more recent evidence that we have about what is an effect size in our field. So even if you have, let's say, an eta square, and you want to know, is this typical or not typical for our field? Is this too strong or is this very weak? And you can go over here and look at the benchmarks and use different benchmarks. And I think in every domain, we have different ways of estimating effect size. This is collaborative, so each one of you can, first of all, come and use this as you like. And then if you contribute something to it and you add your name somewhere over here on the top, there's guidelines for contribution. You add your name and you're a collaborator, so when we submit this. So how to report effect size, the kind of transparency, the directionality, how to interpret confidence intervals, all kinds of useful R packages. So Moot is heavily used over here. But then if you want to calculate something for a t-test, first of all, what are the most common effect sizes for a t-test? Cohen's D, Hedges G, all these things over here. You don't really need to know all the equations, but if you want, you can. But the most important thing, and this is why I'm mentioning here right now, you have some R code. So you take this, copy, paste this, change the variables to whatever it is that you want them to be, but it's all R code, and it even gives you how to interpret the output. So in our guide, for each one of the effect sizes, there is the R code. They can just basically copy paste from here to your RStudio, run this, and then it tells you how to interpret the output. So one way is doing it like that. Another way is, of course, going and doing a report by easystats in order to give you a complete report on how to interpret this, and it computes the effect size and the confidence intervals for you as well. So you've got independent sample t-test, you've got the pair sample t-test, you've got counts, ANOVAs, all of that, correlations. Yeah, remarkable stuff by Chinyu over here. And if you don't know something and something is missing, you can add a comment in the guide, and then we'll add this for you. Occasionally, some student asks something that we didn't add, so we try and add this as fast as possible. What can you do with effect sizes? Aside from reporting effect sizes, you can also use effect sizes if you've analyzed this from previous literature in order to conduct a power analysis. So that's another guide that we have, which is in this URL. And once you have a power and effect size, so for example, if you have a Cohen's D, how to calculate what is the required sample size. So over here again, we have the R code for you. We have the output for you. You just copy, paste this to your RStudio, and that's it. You're ready. All is done. So Chinyu over here really did this for the most common tests that are currently conducted in my course. Plus, if you need more complicated stuff, we also refer to some Shiny apps, or we have links to JAMOVI, not JAMOVI, JPower calculations. So we try and update this. This is a collaborative effort. So at the end, hopefully, we'll have a very elaborate guide. But yeah, very, very detailed. 60 pages. This is 16 pages. So amazing stuff with Genio. So all this is available from my website under the resources, and you can at any time come and pick this up. Effect size and confidence intervals guide or power analysis guide. Doesn't seem to generate the results. It just shows me. So hopefully that's a good introduction to the power of R. If hopefully you thought maybe if R was somewhat too complicated for you before, maybe now you have some idea of how easy it can get. However, based on the questions in chat, I completely understand that sometimes things don't work out of the box, and sometimes you need to know how to diagnose things. So it is a programming language. You do need to know some stuff. So this is kind of like a teaser for you to get an understanding of the power, but you do need to invest a little bit on knowing how to install things, how to load things. And if there are all sorts of errors that come up, you do need to know how to diagnose what is wrong in order to correct the error and load this. In preparation for this workshop, I was looking at the last time that I ran this workshop, I think before the pandemic, like 2 years ago. Things have changed in the last 2 years. So some packages are no longer developed. R moved to 4.1.1. So some packages suddenly don't work. So whenever you have this kind of active development, you need to keep up to date. There's a whole question of how do you make sure that everything is reproducible for the long term. So let's say if somebody opens this 10 years from now, if you open this 10 years from now, how do we ensure that everything can still be run? R is getting better at this. So now there's all sorts of solutions like Docker, like Binder, even RStudio Cloud. Recently, I even saw some efforts by the open science community and the data collada people who did some packages in order to help you save what version of a package you're running and which R version, which RStudio version. So we are getting better at this, but this is for a whole other workshop. This is now we're focusing on beginner. Don't want to scare you too much. I want you to focus on things that are doable. Afterwards, there's something to consider. Once you know how to run R, how do we ensure that R can really be run long term? And it's not just R, but also when you run things in SPSS or you run things in SAS or any other thing, then you need to make sure that even in 5 years, you'd be able to open this, even if R was updated and RStudio was updated. That's a whole different level of complexity. And we'll deal with this a little bit later in a future workshop. R Markdown. So what is this R Markdown? I showed you a little bit with the RCommander to give you like a teaser of some of the exports that you can do to Word or PDF. Let me just go over here. I'm going to close these, close this one. Yeah, so this was our untitled one. Yeah. Okay, so when you go into File, you have the capacity to go a new file and open a bunch of things in here. Now RStudio even runs things like Python, and you can do HTML and CSS. It's like a very robust IDE. It does a bunch of things. We're gonna do R Markdown here, and already you can see that with R Markdown, you can do some pretty remarkable stuff. You can actually do a presentation. You can do slides. You can do a Shiny app. You have a template for all kinds of things like a business card, HTML editor, APA-style manuscript, a revision letter, GitHub, all sorts of funky stuff, even an interactive tutorial that will introduce our Markdown to you. Actually, let's go with this. Let's do an interactive tutorial. I'm curious what that looks like. Yeah, so you'll see it opens this kind of thing. where it gives a title. This we already saw, this is an R chunk. Here we have something with 2 dashes, 2 hashtags, 3 hashtags, then there's a star, then there's a text, then there's another chunk of code, then there's 3 hashtags. So what is going on over here? It's very confusing. But to remind you, R Markdown is a combination of 1 text, 2 code. So we know that the code is in between these chunks, and actually we can collapse them or we can run these codes. Now, what's interesting is that actually you can see that I can jump between these sections. So actually this topic 1, this is a heading, this is a subheading. So you can see topic 1 is over here, topic 2 is over here. If you can't see this, you need to toggle this thing. Plus, the latest RStudio has something really interesting, and this is called visual mode. So you can switch to visual mode. Yeah, so you can see this is visual mode. It's a bit like Word. It allows you to very easily kind of manipulate this. So you write this as if you write the regular Word document, but every once in a while, it has an R code that you can actually run. So this gives you all sorts of things. So for example, here you can run the empty cars, and it will show you the results if you go to the syntax mode. So it gives you, this is a data set of cars. These are the columns. Now, the nice thing about this is that all of this, you can actually export to whatever. So you can run this document, since this is a tutorial. So you can supposedly run this, and it will tell you what to do and take you step by step in doing that. But generally, when you write these kinds of things, you see the tutorial over here. Here's a simple exercise with an empty code. So you can run the code, you can run this code over here, run this code, you can start again. Next topic, you can move. So R Markdown really allows you some remarkable things. We'll stop with this tutorial and go to our regular one. Let's start a regular one, so I can show you a regular one. So this is what a regular one looks like. And the nice thing is that here, instead of previously we had run documents because it was a tutorial, now instead we have this knit. So we know how to look at these things, but now we can knit this, and we can knit this to HTML, we can knit this to a PDF, and we can knit this to Word. So if we knit this to HTML, for example, yeah, let's do this R Markdown. So it will do some, sorry, how do I run it in the viewer on the bottom right panel? Oh, okay. So in my case, when it's HTML, it opens it on the viewer, but you can always, of course, open this on your web browser. For some of you, maybe automatically it opens in the web browser instead of open it over here. And this is something that you can actually define. Go to Tools, Global Options, but yeah, it's somewhere here. So it's an option that you can, so I prefer to have it over here, but you can always export this also to your browser. So as you can see, just by me knitting to an HTML, it already created this one here where we have a heading. So this is heading 2, right? This is our text, and this is our code where it summarizes the cars. So this is a data set that's called cars. This is a plot. So you can see, for example, over here, plot pressure. So now you can see the plotting of the pressure. And you can insert all kinds of code in here, ggstatsplot. Now, you can also use this as a regular editor. So actually, one of the add-ins that I included is one that tells it, I want to do heading 1, heading 2, heading 3, heading 4. So for example, I want to do heading 5. So it's 5 hashtags. This is heading 5. And as you can see, it included this heading 5 under the heading 1. So afterwards, I can, I did this kind of thing. I can also do some stuff that is, let's say, add in that is, I don't know, like a quote or something. But then I can knit this and make this into a PDF. Takes a while to run. And then, So the nice thing about R Markdown is really it combines both code and text, and then it can very easily be exported with all the headings and everything that we need, heading 5 into a PDF that we can save. Some people in science write their documents this way, so their manuscripts. The nice thing about this is that if you do this correctly, the one thing that you can do is that you can create one R Markdown that runs on all your code. So instead of having one Word document or Google Doc, and then another set of RStudio code, you can blend these together, because in your results section, you have a lot of results that are running on R. And then everything that appears in your manuscript comes from your analysis on R. So you have one manuscript that has both your, whatever you wrote, your introduction, your methods, but also has the code, and export this immediately into your results section. What's nice about this is that if you have a new data set, you don't have to write the manuscript again and do a copy paste from your RStudio export into your Word document. You just go and do knit. You change whatever you need in the code, you do knit, and that's it. You have a new manuscript, and it automatically updates all the text for you. May I ask how you created the preview just now? Yeah, so over here on the right, first of all, we can tag the headings. And the second thing is that you see here, this switches to visual mode. So I can switch this to visual mode, and then I can just use this as if I'm using Word. So because this was supposed to be a quote, this is a quote. But here, enter anything else. There's one last thing I want to show you, because I don't know if you're familiar with the stuff that I do. But I associate myself with a big group that's called the Open Science Movement, Open Science Group. And we care about open science, and we try to do things like replications and extensions. We try to do assessments. We try to do all sorts of things. And we develop all kinds of tools in order to try and assess the current literature, or try to make sense of the literature. So the last tool I wanted to show you is what's called a Shiny app. Once you become familiar with R, you'll be able to also develop Shiny apps that offer an interface to other people in order to run R without them knowing that they're running R. I'll give you one example. For example, one of the biggest problems that we have in our literature is that nobody has ever checked if in any of the article there's a problem with the statistics. Sometimes in many of the articles, they reported some statistics that, for example, they reported a t-test, and they did the t, and the degrees of freedom equals to the t-statistics, and then they reported a p-value. And many times these p-values are incorrect. How do we know that they are incorrect? We can extract the information from these documents, and we can run an analysis on them. So Michelle in the Netherlands did her PhD on this, and she developed a package called Statcheck, which is quite remarkable. If you go to the Statcheck Shiny app on the internet, it's wonderful. What it allows you to do is that once you wrote a manuscript, or if you see an article, you have a PDF or an HTML or a docx, you can go over here. This is a Shiny app. You can upload your document. So for example, here I already prepared one of my documents in order to make sure that I can run this on mine as well. And what it does, it takes the PDF, it extracts all of the statistics from that PDF, and then it runs an analysis to check that I don't have any statistical errors in it, which is quite interesting, I have to say. So many times before you submit, you want to try and do this. If you try and submit to Psychological Science, which is considered to be a reputable journal in psychology overall, then they do Statcheck before they take this. But many times we don't do Statcheck. So you can see, for example, it took this from my article. So this is an article that we did together, me, my students, and Jane Chen, who joined us as an early career researcher. And this was published in SPPS. So it extracted all of this from the PDF and automatically computes the p-value. and then checks if my p-value that I report, so p lower than 0.05, is equal to the computed p-value. So it's a spelling checker for p-values and statistics, which is quite remarkable. It's really quite amazing. There's like, for example, there's one inconsistency here. So here we reported 0.00 for some reason, and it's 0.0057. So there's inconsistency, and then you can decide, is this serious, not serious? Is this a rounding issue or not? But if you're going to submit something to a journal, you run a spell checker. You run things like, for example, recite works in order to check your references. Do you know recite works? So you can check all your references. You upload the references here in order to make sure that all your references are correct. And you want to make sure that all your statistics are correct. So Statcheck, this is a Shiny app that runs on R that allows you to do this sort of thing. You can also do this in your RStudio. So, but the nice thing is that you can actually do this within a Shiny app online with Statcheck. Another remarkable Shiny app, just to show you the power of Shiny apps, is this Shiny app. It's called pChecker. So if you are planning to do a thesis on a literature and you want to know, is this literature solid? Is the evidence, does it seem credible or not? Actually, you can take the entire literature, you can take all the statistics, and you can do a mini meta-analysis. I think somebody was asking me before, can you do a meta-analysis with R? You can do everything with R. The question is, of course, how much effort do you need to put into this? So I'll give you, for example, this is a Shiny app. Everything that runs here is on R. Everything is open source. You can look at everything that they've done. You can see some demo data, for example, taking the t-statistics from one of the articles. You can put your own in here in order to check that everything is okay. So you can see over here, this is Statcheck, p-value is correct. And exactly like I showed you just now with Statcheck, you can do this check over here to see whether this is reliable or not. Plus, you can do a mini meta-analysis. So for example, let's take some kind of literature. For example, I don't know if you're familiar with the so-called replication reproducibility crisis or the science reform, but if you are, we can't seem to replicate power posing or elderly priming very well. Some people like Daniel Lakens already prepared a data set for us. So these are all the findings of the elderly priming that we know of from 2002, 1996. So basically, Daniel Lakens went to the articles and took out their ANOVAs and their p-values. The first thing that we can do is look at the p-values, are they correct? There are some problems, and you can flag a few problems, and then we can decide, are these big problems or small problems? These doesn't seem to be big problems, but we can also do a meta-analysis, which is amazing. You just click on a meta-analysis. It does a funnel plot. Then it gives you the overall effect size, which is Cohen's d of 0.5. And then it gives you even bias-corrected effect size estimate. So if you do some corrections, according to if there's a publication bias or not, it seems like really the effect size goes and becomes much weaker, and some indication for publication bias. I don't know if you know how to read this, but some big problems here. And you can also run something called a p-curve in order to see whether there's some evidential value in here. It doesn't seem like it contains evidential value. There's some indication also that this was intensely p-hacked. So all this interface is a Shiny app. Everything that runs underneath is R. You can easily extract by using Statcheck all the statistics from the PDF or an article that you're reading or an entire literature, put it in here, do a meta-analysis, do a p-curve, do a Statcheck. All this is a few lines of code in R, and this really interesting Shiny apps that were built on top of that. Once you become a bit more familiar with R, that you know a little bit how to code, you think that doing a Shiny app is difficult. It's not. So I did some meta-analysis Shiny app for some of my collaborators who did not know R, and I needed them to be able to use my R code without knowing R. So I created Shiny apps for them. The first one that I did took me about an hour, and this is when I was still not very confident with my R skills. So A lot of copy paste. This is our superpower. Look at what other people did online and adopt what they've done to what it is that you need to do. So yes, I think this brings us to conclude this session. It's amazing that you lasted 3 hours with me, the 50 brave souls that remained throughout the whole 3 hours. Thank you for staying. Thank you for coming and joining me on this. I'll make everything available. I'll share everything on YouTube. I'll send the links. There will be other workshops in the future. So if you want, you can always go to my website. It's mgt, not this one. You can just do giladfeldman.org, and this will take you to my website. And on my website, there's a mailing list. So every one of our workshops, and if you want more information, go here, join the mailing list, and you'll get updates about everything that we do, all the workshops, all the outputs. And if at any stage you need some help, you want to join some of the stuff that we do in the big projects that we're running in open science and meta science. If there's something that you want to talk about that's personal about the stuff that you're facing or your dilemmas or how to move from SPSS to JAMOVI or to R or how to do open science, then we're very happy to try and help you. I'm available to you. If I can't answer something, I'll probably know who to connect you with, and we have quite a big team, people with lots of skills. So thanks so much. Hope that we can get to talk more in the future. See you in other workshops.